All right, let's just dive right into this explainer. If you've ever stared at cloud computing documentation, you probably know the feeling. It can honestly feel like trying to read a completely foreign language. Well, today, we're going to fix that. We are going to demystify all that dense jargon of Oracle Cloud Infrastructure, or OCI. And instead of just, reading off a boring list of vocabulary words, we're going to help you actually visualize how a cloud environment is built right from the ground up. So, what does it actually take to build a digital city in the cloud? That's the big question we're answering today. Like I said, rather than just handing you a dry alphabetical glossary of cloud terms, we're going to use these definitions to construct an actual digital city. Because when you start thinking of cloud resources as real estate and buildings and roads, the entire architecture suddenly just clicks into place. Okay, here's our blueprint for today. First, laying the cloud foundation. Second, building your compute instances. Third, wiring the virtual network. And fourth, directing and securing traffic. Let's start with the macro real estate. Section 1. Laying the cloud foundation. Before you can build anything, you've got to define exactly where your infrastructure lives, both physically in the real world and logically in the cloud. So, before you pour a single ounce of virtual concrete, you've got to zone your land. In Oracle Cloud, you do this using compartments. A compartment is basically a secure, logical container. It's how you group and isolate your resources. Think of it like drawing property lines so you can organize your network, your instances, and the whole shebang in a way that actually makes sense for your business. Really, you can think of it as the ultimate filing cabinet for your billing and access. OCI keeps everything organized through these containers so you always know exactly who has access to what, and crucially, exactly where your money is going. By grouping things into a compartment, you know exactly which department is spending what, which just gives you ultimate visibility. Now, physically, your city needs a location, right? In OCI, it sits inside an availability domain, or AD for short. You can think of an AD as a highly secure, isolated, fault-tolerant data center that's located within a specific geographical region. This is the literal physical fortress where your digital city actually resides. But how do we handle risk inside that fortress? Well, inside an availability domain, you have fault domains, which are logical groupings of hardware. Imagine lightning strikes a power grid, or maybe a physical network switch fails in the data center. Your app stays online. Why? Because you wisely placed your hardware across different isolated fault domains. They don't share the same physical power or network hardware, so it completely prevents simultaneous failures. It's a real lifesaver. And here's a key thing to remember. Every single piece of real estate, every building, every resource you ever create in this city is tracked. Oracle does this using an OCID, or Oracle Cloud Identifier. It's a unique, internal string of characters. Think of it as the digital deed, or the absolute unique serial number for literally every single thing you build. All right, moving on to Section 2, building your compute instances. Now that the foundation is poured, let's construct the actual buildings where all our work gets done. Building, or what we call provisioning a server in the cloud, is a very active step-by-step procedure. You don't just click a magical button and hope for the best. You've got to first pick an operating system template, then choose your hardware specifications, and finally add your primary storage so the system can actually turn on. Let's break those specific terms down. It is incredibly common to mix these two up, so let's clear the air. The image is simply your operating system software template. Think Ubuntu, Oracle Linux, or Windows. The shape, on the other hand, is the physical floor plan of your building. The shape template dictates exactly how many processors or OCPUs you have, how much RAM you get, and your network bandwidth. So, when you combine that image and that shape, boom, you create your instance. A compute instance is the actual virtual machine or bare metal server running in the cloud. Going right back to our city metaphor, this is your completed building. This is the virtual private server where you'll actually host your apps, your databases, or your websites. But of course, a building needs storage. To store your data and actually turn the instance on in the first place, you need a boot volume. This is your primary hard drive created specifically to hold the operating system. But hey, as your business grows, you're going to need more space. And that's where a block volume comes in. You can attach a block volume to your instance, and it functions just like a highly durable virtual external hard drive, or kind of like an extra storage shed out back. So how do you actually get into these newly constructed buildings from the outside?
Well, you definitely don't use a standard, easily guessable password. No way. For Linux instances, you'll use SSH keys, or secure shell keys. This is a pair of cryptographic keys, one public, one private, that lets you securely log in over the public internet without ever typing a single password. It's absolutely crucial for security.
Okay, Section 3, wiring the virtual network. We've got the buildings, but they're completely isolated out there. Let's wire up the network. Everything here starts with the VCN, or Virtual Cloud Network. Your VCN is a customizable, private network that acts as the absolute foundational infrastructure for your cloud resources. It essentially outlines the private city limits for your environment, and it functions exactly like a traditional physical network would in an old-school legacy data center.
But obviously, you don't just want one massive, chaotic road system. You organize that network by dividing your VCN into smaller, logical blocks called subnets. For example, you'd probably put your public-facing web servers into a public subnet, so anyone on the internet can reach them. But you'd keep your highly sensitive, mission-critical databases safely isolated inside a private subnet, tucked far away from any public traffic.
Now, you might be wondering, how do we determine how many addresses actually exist on these new streets? Well, the number of IP addresses available to your VCN or to a specific subnet is dictated by CIDR, classless interdomain routing. I know, it looks a bit technical, usually like a network IP followed by a slash and a number, but honestly, all it really does is dictate exactly how many IP addresses are available on that specific block of your street. And to finally connect your building, your compute instance, to the street you just paved, you attach a VNIC, a virtual network interface card, bridges your compute instance directly to a specific subnet within your VCN. Basically, it's the physical driveway connecting your server right to the network infrastructure. Which brings us to Section 4, directing and securing traffic. The infrastructure is totally built out. Now, let's install the traffic lights and security guards to manage the flow of data. First off, if your instance is in a public subnet and needs to talk to the internet, it gets assigned an ephemeral public IP. This is a temporary public address. But listen, the keyword here is ephemeral. Be warned, if you delete that compute instance, this IP address is released back to Oracle permanently, and it's gone. So, don't get too attached to it. Once your instance has an IP, how does its data actually find its way out to the internet? Well, your traffic is directed by route tables. These are sets of rules that act exactly like street signs, pointing your data packets in the right direction. For instance, a route table will point internet-bound traffic out through an internet gateway, which is really just a virtual router attached to your VCN that allows direct communication with the public internet. Finally, we've got to secure all of this traffic at the packet level. We do this using virtual firewalls known as security lists or network security groups. To configure these, you have to specifically define your rules. Ingress rules dictate what outside, incoming traffic is allowed into your instance, like, say, allowing web traffic on port 80. Egress rules, on the flip side, dictate what outgoing traffic your instance is actually allowed to send out, like letting your server download essential software updates from the internet. And just like that, the jargon is demystified. You now understand the foundational blueprint of Oracle Cloud infrastructure. You know how compartments organize your land, how shapes and images build your instances, and exactly how subnets, gateways, and security lists wire your virtual city together. So the only question left for you as a focused learner is, now that you have the servers and the roads, what are you going to build next? Thanks for joining me on this explainer, and I'll catch you next time.